Before we get going on that, I wanted to ask you, the way I do always let my courses run are, I let you choose the date of your first test. Now, in the summer, it's accelerated. And anytime's fine with me, but if I was sitting where you were, what I would want is probably somewhere over the halfway point, the first exam. You can have it anytime you want, remember. Now, you know your exam schedules for your other classes, don't you? I'd like to do this on Monday, because I didn't say anything about this prior. On Monday, we'll put up suggested dates and you'll vote on it, all right? You all with me on this class? Has anybody had me before? All right, you know, this is the way I like to do it, so you pick the date. It doesn't matter to me. I'm just gonna suggest, don't do it as soon as possible, because then, honestly, this is my opinion, come final exam, especially if you do well on the first exam, right? People tend to get complacent. I got this. And then a bunch of material comes through. The final exam is cumulative, and people sometimes just drop the ball on that one because they think they got it. So I'm just telling you this, and remember, it's closed book, closed notes. I may give you some formulas and things like this and tables that you'll need, but it's reliant on the fact you're familiar with all the homework and you've been keeping up with it. But you can choose the day. Any questions about that? One other thing, I don't think I said this in here. I may have on the first thing. You can have a cup of coffee in here and stuff. You can have things that don't make a lot of noise, like potato chips and things that don't crumb up the place. All right, you're allowed to have that. But if you, for whatever reason, do make a mess, please clean it up. That's the only thing I ask you. This isn't that big of a deal because there's no carpet here, but in some of the areas it's a problem. Any questions before I get going? All right, how many actually looked at the homework and stuff? I'm gonna go through the homework and I'm gonna try to tell you right now, we're dealing with continuous variables and probability density functions. Before, well, for the most part, before we did discrete, I'm gonna go through the binomial, Poissons, and hypergeometric in more detail in a little bit. But right now I wanted to jump to the continuous domain and the prior book, and I'll give you problems out of our book too, but I'm gonna use that one. Even Tom Denny's slides that I'm referencing, use that. So.
Dr. Baginski.
Yeah.
I have a question. Is the quiz still gonna be on Wednesday?
Yeah, I'm planning to have a quiz this Wednesday. So Monday, we won't have one, but Wednesday, if that's all right.
And Friday?
No, we won't. I'm gonna do one Wednesday. We'll probably skip Friday, and then we'll just pick it up on a regular schedule, okay? I could do it on Monday if you want.
So like a quiz on Wednesday and then next week, Monday and Friday?
No, quiz on this coming up Wednesday, skip Friday, go to the next Friday quiz.
Okay.
All right, that's what I was planning. But if you want it Monday, I'll give it to you on Monday. This is problem 2.21, I believe. And this is discrete. I'm just gonna go through this stuff. Didn't I give you 2.21?
Yeah.
Or 2-2-2.1, yeah, I'm gonna put the binomial distribution thing of k of n equal n factorial over n minus k factorial, and it's p to the k, 1 minus p to the n minus k. This is have k successes where you have n possibilities, or n trials, you might say, k successes. Okay, go ahead. Can somebody read that for me? Anyone?
It says when 10 coins are flipped,
Okay, 10 coins.
the event of interest is the number of heads.
All right. Okay, so they want the number of heads. Go ahead.
And then let this be to the random variable, and then part A is plot.
So
the
x is
distribution.
really just the number of heads, right?
Yes.
Uh-huh.
And then part A is to plot the distribution function for
I-
this random variable.
I did this on MathCAD. I could show you it, but it's a stem plot, and you can do it on MATLAB, anything. Did anybody do this, by the way? It's just a Gaussian kind of curve. It looks like this, basically. It's not really Gaussian, so it's gonna look like this. This is gonna be 0, and this is 10, and this is number of heads. The only thing we're doing here is gonna start rastering. We go P of 0, 10, P of 1, 10, P of 2, 10, 3, 10, all the way down. It's symmetric about, somewhere around, yeah, I think it's 5, and it's gonna do this. And then you're gonna see this, I did this, and I have it. But it's just showing you, basically getting you familiar with that. That's the distribution, and the peak will be in the center right there.
So in his answers, he had it going like all the way up to almost.
No, this is the density function. This is the probability of the number of heads. He has the cumulative distribution function.
Okay.
All right, it's called the PMF, it's the probability mass function, and this is just like the actual probability density function in the continuous time. This is what I'm showing you. Now, when he has the cumulative distribution, what he's gonna do, and I'll do it over here. Now he goes from 0 to 10, and here he's gonna plot, I'll call this P of K here, and this will be K. And that's really gonna be a sum that starts at 0, or K equals 0, to, I can't use K, how about? I'll use I equals 0 to K, and this is going to be of P of K comma 10. And it's a sum, so if K equals 0, it's just the first term. And that would, what would that be, by the way? If you look at this, what is P of 0, 10? Well, 10 factorial over 10 factorial gets rid of it, that's 0 here, right? So this goes away. Then I have the probability of heads is gonna be 0.5 or 1/2, right? Times this, well, if the probability of heads and tails is the same, this is just gonna be to the 10th power, is it? 1/2 to the 10th, correct, class? So this is just gonna be equal to 1/2 to the 10th power. Let's see. 2, 8, 16, 32, 64, 120. What is that, 1025 or something like that? 1024? Anybody know what this is on top of their head? What's 2 to the 10? 10, 24, 20, 48. I'm not sure, actually. I hate doing these things.
Why 024?
It's 1 over 10, 24? Okay, so that's what it is down here. It's 1 over 10, 24. You got your calculator out. Would you do me something? Would you calculate this P of 5, 10 right here? I mean, do you have the binomial thing in your calc?
Yeah.
I'm just trying to get a feel for this. This is gonna be fairly large. This is 0.2, did you say?
246.
246. Orders of magnitude greater, right? And so then over here, it's a summation. The only thing it does is this. It's gonna start here at some finite value, and it's just gonna ramp up. It'll go like this. It'll have something like this where it's just ramping, ramping, ramping. When you hit 10, it's gonna have a value of 1. That's the only thing he's showing you. Y'all follow me on this, class? Now, the second part of that one, and this is, again, this is based on just the counting principle. We did many problems like this in the past, right? Try it in your calculators, because I'm gonna ask something like this. So you might as well get used to using your calculators. The next part is what?
Part B is what is the probability that the random variable is between 6 and 9 inclusive?
Okay, so anywhere, it could be six heads, 7 heads, 8 heads, 9 heads, right? That's it. Now, the way I normally think of these things and do them, I use it with the density function. I just integrate or sum all the probabilities from 6 to 9. Y'all follow me? The summation would just be this. The probability of the random variable of number of heads being between 6 less than or equal to 9. This might be wrong in this book, by the way. It's just this. It's going to be a summation of that from I equals 6 to I equals 9 of this P of I comma 10. Can you all follow me? Yeah. Can your calculator do this? I mean, these calculators should be able to do this very quickly if you're used to them.
Yes,
Yeah.
0.375.
And I think that's his answer.
0.376.
0.376. There might be a rounding error. Y'all follow me on this?
Yeah.
Is that the right? I think it's right.
Yeah, that's right.
All right. What's the next part? We did lots of these, but just to be sure.
Greater than or equal to 8.
Greater than or equal to 8?
Yeah.
How do you do that one? You got a couple of choices, right? You could have, what? You could sum P of 8, P of 9, P of 10, right? Or you could take 1 minus the probability of 0, 1, 2, 3. I think it's easier the first way I said, right?
So it'd be 1 minus that.
The sum
of
all the way to
7.
7. But that's a lot of, if you're doing this, just, punch and repeat, take forever. If you got a program to do it, it's nothing. And I did it on MathCAD both ways and it's done. Did anybody use MathCAD yet? I'm gonna encourage you, just try it. Try it for 1 week. Any questions you have, I'll show you. It's so much quicker than any other program I've ever had. I can do these problems. I literally whip through these things in 15 minutes. As fast as I can just type these things, it's giving me answers. And I can change anything on the fly. So the probability of, here it's gonna be of between 8, it's really greater than 8, right? So the probability of 8
Or equal to 8.
of x and less than or equal to 10, right? So that's just the sum here. Simply a sum of I equals, in this case, 8 to 10 of P of I comma 10. And that's a simple sum. I think you can program this kind of thing in your calculator. It's a simple binomial. What's the answer for this one?
0.0547.
All right. Quite a bit less, over about one fourth that. Of the peak value there in the center, and a lot less than that. All right, what's the next one?
That's it.
This is just getting familiar, and with your calculators, really, that you can do these things efficiently. Here's what happens on a test, oftentimes for quizzes. People don't use their calculator to do the problems. They just think, I got this. Then I ask a problem with larger numbers, maybe 100 variables, and you're not used to doing things like, if you got something where you got, say, I want the probability of 30 out of 40 here. You got 40 factorial here over this. These numbers start getting big and your calculator will give you an error. Hear me on this one, everyone? And you're gonna say, well, my calculator, no, here's what the problem is. You didn't divide this out first before you put it in. Because if you have 40 factorial and you want 30, so this would be what? 40 minus 30, right? Factorial, which is 10 factorial. This would be 30 factorial, and you can see the canceling going here. There's a lot of cancellation first. Over here, you can't do anything, you gotta do that. You with me, class? The next problem is 2.2, or 2-22, right?
Yes.
Okay, let's just do it. I'll try to whip through these. I'm really not trying to bore you, but these are problems that are directly related to what we've been covering. And by the way, what is the mean value of this? Do you remember? We talked about the mean and the variance for these kind of processes. How many heads? What's the mean value, remember? Of a binomial. You said it. Say it. It's what? The number times p, right? Isn't that the mean? This would be the mean value. What is that? 10 times 1/2 is 5. Shocking. Who would have guessed? We've got the equal likelihood, right? And what is the standard deviation? Do you remember that? It's what? What is the variance? Sorry, what is x squared? What is this? What is VAR of x? What? That's right. And that's gonna be what? 1/2, right? And that's 1/2 too, so it's 1/2 squared times 10, that's what? 2.5? And what's the standard deviation? And what's that? What's the square root of 2.5?
1.58.
1.58? All right, now you've got other aspects of this problem I could ask on a quiz. Hint, other aspects of this I could ask on a quiz. When I say that, you put a star, like circle it, underline, whatever it takes, yellow it. Make sure you don't forget it. How many have had me before? How many remember me doing this? How many know that that's the way to, it's coming at you? The fastball is coming, and that's it. All right. Next part. Yeah, I know you know. You sat in the front all the time. You looked at me like, what are you saying? What's the next one? 2.2. Go ahead.
So for random variable has a probability distribution function given by fx.
All right, this is a PDF. So this is the PDF function. PDF of x is equal to,
0, y is from negative infinity to minus y inclusive.
to what?
Negative 1
Negative 1. Okay.
inclusive.
Go ahead.
And it's 0.5.
Plus 0.5 x, right?
Yeah.
And that's from minus
1
1
to
to
1.
minus 1 greater than or equal to x, less than or equal to 1. Go ahead. And 0 else, right? 0 for.
It's 1 else, but
It's one- Oh, this is not this. This is the f of x. This is the cumulative distribution function. The capital F of x in our book and his book means it's basically the integration of the PDF from minus infinity to the point x. Y'all follow me? So this, as x goes to infinity, has to be 1. You're integrating the PDF, or the probability mass function, summing it over all possible values. The probability of it happening has to be 1. We're talking about something that's of no importance. Y'all with me, class? So here, it's going to have this is equal to 1 for x greater than 1, right? Now, I'm going to do something that's a little different. The first thing I'm going to do is get the probability density function. Y'all hear me? The probability density function. So the PDF of x is really the derivative of f of x. I hope you saw what I put on OneNote where for taking the derivative of this, you have to, if this is basically an integration, f of x of the PDF, right? You have to evaluate the actual function small f of x at the value of the top, but then you have to take a derivative of that function on the top, where the limit is on the top, and do it that way. We'll talk more about that. That's Leibowitz or Leibniz, sorry.
Yeah, Leibniz or Leibniz.
His rule. Anyway, so I'm going to just do this. What's the derivative of this? Well, it's equal to 0 for x greater than minus infinity less than minus 1, and it's equal to 1/2 for x greater than minus 1 less than 1, and it's equal to 0 else, right? I like to think of things this way. I think it'll help you. So now I'm going to graph that function. I'm just going to graph the PDF here, or f of x, small f of x, here, versus x, and let that be 0. So from minus 1 to 1, it's simply 1/2, right? And that's it. Now, please get this in your mind, and I'm not trying to just bore you with this stuff. Does everybody follow me on it? That's a density function. So the possibility of any values is just over any range is really the integration of that function over the range. That's all it is. We'll get the mean and the standard deviation, the variance and stuff like that too. But do you all see this? I'm just asking you, if that's the density function, what do you think, just by looking at it, the mean value is? Think. Yeah, right? You all follow me? If you multiply, and think about this, the possibility of being less than 0 is the same as the possibility of being greater than 0, almost guaranteed at 0. As a matter of fact, for any function that's symmetric about 0, including Gaussians, the mean value is 0, but the standard deviation, the variance and the standard deviation aren't. We'll talk about that. We'll do this problem, then I'll go through some more of this. Anyway, I'm going to erase this and continue. I hope I'm telling you the way I'm thinking, because I think it might help you. I don't teach this normally. I use a lot of this in Radar, but I don't teach it. But I'm trying to tell you what I've extracted from this course when I was sitting where you were that really is meaningful. I don't try to memorize solutions to Merlot problems and all. I try to see what's useful in my area. Go ahead. What's the next part? Anyway.
Find the probability that x equal to 1 false.
Oh, this is good. Equals 1/4. You know what that is? Technically, it's what? It's the integral from 1/4 to 1/4 of f of x dx, all right? What does that gotta be? Look at f of x. This is finite, right? This is 0. You all follow me on this? It's 0. And he's just keeping you, the probability of having exactly a value 1/4 is exactly 0. Now, if it was a probability mass function, where you're using stem plots, where you could have discrete values, then it may not be. You all follow me, class? But this is a continuous function. He's just making sure it's in your brain. What next?
Find the probability that x is greater than 3/4.
All right. Some of you probably got this and you're almost bored. So this is the random variable greater than 3/4. What's that gonna be?
Integral from.
The only thing it is what? Technically, it's just this area, isn't it? Integrate f of x dx. Or you could take what? 1 minus the integral from -1 to that, right? Either one will get you the same deal. How many see this right here? I'm not trying to move too quick. You'll follow me on this? It's not hard at all. So what's that value gonna be?
3/8.
So it's the height is 1/2, right? And what's the distance this way? This is, you said greater than what, 3/4?
Yes, 3/4.
All right, so this is only a quarter, isn't it? Is that right?
Yeah.
So that's gonna be 1/2 is the height times 1/4, that's what? That's 1/8. Do you agree with that?
Yeah.
Does it matter that it's not equal to 3, like it's just greater than?
Greater
So-
than or equal.
So do you include 3/4?
You can, but it doesn't matter. Here's why. Because this is a continuous function. And I know mathematicians get irritated at this. But it doesn't, if you're at a value of 3/4 or 3/4 plus delta x, it makes no difference if delta x in the limit is going to 0. Do y'all follow me? When we have this, I'll talk about things that are discontinuous and how you evaluate them. There's a couple of different things you can do. There's the Gibbs phenomenon, there's all sorts of stuff that goes on. But for this type of problem,
Doesn't matter.
that's it. I mean, I could write out integration, but y'all see this here, class? Just the area under the curve from here to here. Height times width. Height is 1/2, width is 1/4, it's 1/8. Is that the right answer? Okay, what's the next part? I'm sure it is. Go ahead. You with me?
Yeah. Probability that from negative 0.5 to positive 0.5.
All right, so I'm gonna erase this, but I wanna make sure you see this the way I like to look at it. Now, the way he's gonna do it, he's gonna have the integration of this, and he knows that the f of x function in his book, the cumulative density function, f of x is technically the integral from -infinity to x of the density function I've graphed here, dx. So if you wanted the probability, and I'll put it here, probability of, give me the values here for x again, greater than,
Negative 0.5
all right.
to positive.
Now you can do it two ways. If you want to use a cumulative density function there, all right, then it would be really f of, and it would be positive 0.5, because that would be the integration from -infinity to 1/2 minus f of minus 0.5. Do you all follow me? That'll work. The way I do it, I take one look at this, and I'm going from -1/2 to 1/2, and it's this area. Well, the height is 1/2, the width is 1, it's 1/2. Do y'all follow me? So this is just 1/2. Not trying to be funny about this, but it seems obvious to me after you see it. There's a few things that get a little screwy, but this should be pretty obvious. Go ahead, next one.
I think now we're on to the next problem. This is,
That's done?
that one's done.
All right, hold on for 1 second. But I want to do one thing here. So keep this density function in mind. Here's a probability density function right here. I want two other things.
I'm telling him what page to go to for the problem.
Oh, so next thing I would ask this on a quiz, typically something like this. Next, I want the average value by looking, class, what is it? Average value, expected value is expected value of the random variable x. Here is going to be, look, 0, isn't it?
So it's just the mean.
It is, the mean is the expected value. Y'all follow me, class? Can everybody see that just by looking? We can do the integration, but it's a constant integrated from -1 to +1. It's gotta be 0. Y'all follow me? What next?
The next problem.
I mean, it's x times it, yeah. Oh, it's the next problem, okay. One other thing, sorry. I want, let's get the mean squared, the second moment. How do you get that? Second moment is technically what? It's the integral over the range from -1 to 1 of the variable x. Now it's squared, right? This is the second moment I want. And it's times the density function, which is 1/2, right? Integrated dx. Do y'all follow me, class? It's just x squared. Matter of fact, in general, when you want the expected value of any function g of x, you'll have this kind of an operator. The only thing that's going to be is an integration, technically from -infinity to infinity, of the density function, but first you put g of x here, and then you put the density function, whatever it is, dx. Now remember, f of x is 0 from -infinity to -1. It's 0 from 1 to infinity also, right? So technically these limits for our problem just go from -1 to 1. All with me? Then it's the expected value of what's in here. In our case, it's x squared. So that goes there. What's this value going to be? This is 1/2, it's a constant density. Integration of x squared is x cubed, right? Over 3, and that's what? That's going to be 1/6, and then here, well, when you evaluate it at 1, it's 1 minus -1 cubed is going to be a -1, so it's +1, and this would be 2/6 or 1/3. You all agree? Very straightforward. You should see this. You good with this, class? All right. Now, how do I get the variance right here? Remember, we could do what? We could take this and replace it by x minus the mean, right? But what's the mean? 0. So it would be just this, right? But to prove it, how would you get that? Well, remember what that is? It's what? The second moment squared minus the mean value squared. Do you remember that from last time? How many do? If you don't, it's okay, but just I'm showing you the trick. It's simple. This we use all the time. We use it in radar, use it in so many other things. It's used all the time. And you're going to see when we get to the Gaussian distribution, the normal distribution, you're going to see what, when they talk about standard deviation and mean, really represent. And there's things that have to do with how sharp the density function is and how symmetric it is that have to do with second and third moments. So what's this value going to be? It's just this value, right? 1/3. Because the mean is 0, correct? I'm showing you this, trying to show you more than just the problem, what it has in the problem. All right, let's do the next one. I hope I'm not boring you with this stuff, but.
So the next one is 2-tech 2.3. It gives another probability distribution function for a random variable x has the form.
This is f of x, right? Capital F of x?
Yeah, capital F of x.
Go ahead.
And it is capital alpha, or A,
Oh, sorry. 1 minus
1 minus exponential,
x minus 1, is that it?
and it's negative, parentheses, x
Oh.
minus 1.
And this is for what?
And that's for x is greater than 1 but less than infinity.
All right. And 0 else?
Yes, 0 for negative infinity to,
Just else.
yeah, 1.
All right, so I think they want the value of A, right? Now, hear me on this. They gave you f of x, capital F of x. That's the probability. What does this stand for? Well, f of x, again, is the integration from -infinity, technically from -infinity to x of the density function, f of x dx, right? That's what it represents. What does that have to be as x goes to infinity? Just think.
1.
It means, what's the chance of it being from -infinity to infinity? It's got to happen, right? 1. It's 100%. Follow me on this, class? Y'all with me? You look suspicious. I think there's a trick. No, that's all it is. Y'all. So what's A? Just by looking. What happens to this when x goes to infinity? It goes to, just the exp is, what's exp is minus infinity is 0. So 1 times a is 1, a is
A.
1, right? A is 1. You know, I get answers on tests when kids don't know what they're doing. They try to be a little funny. So, one time, I said, find some value. And the kids circled it. There it is.
Oh, that's genius. He's correct.
I've seen these things. I've seen clips for things teachers have seen. And oh gosh, it's crazy some of the students do. Anyway, y'all with me on this class? It's 1. Now what else?
And then for part B, it's what is f of x of 2?
Capital F of x?
Yes.
What's it gonna be? Just look. F of 2 is just 1 minus exp, right? Of, and this is gonna be minus 1, isn't it? Correct?
Could be -2 minus 1.
It-
Or
it-
negative 2
It's
plus
2
1.
minus 1 is 1, right?
Mhm.
So it's a minus sign, e of minus 1, isn't it? Y'all with me, class? It better be the right answer. I don't know what that value is, but did you have a question about that? I'm just substituting in the value 2 there. He gave me a mathematical function, I calculated a. Now I can get the next part just by sticking the value and evaluating it, right? There's no trick. What's the next part? Is that the right answer, by the way? I hope that's right. I hope, yeah. What's the next part?
What is the probability that the random variable lies on the interval from 2 to infinity?
Okay, so from here, this is 1 to infinity, right? For 2 to infinity, what's the probability of the random variable being between minus infinity and plus infinity? 1. All right, so how can we do this? Let me just write this down so you have a visual. We're going to get, I'm going to actually ask you how you get the mean, the second moment, and the variance, and the standard deviation. So here he has the probability of the random variable x being what? Yeah.
On the interval from 2 to infinity.
From 2 less than or greater than random variable infinity, right? So we can take the actual f of x of infinity. I'm just putting this down for help, and then we can take f of x of 2. Do you all agree with that? If we had a density function, we'd integrate from 2 to infinity, or you'd take 1 minus the integral from 1 to 2, right, of the density. You all follow me? It's either way is going to get you the same answer. So this is what? 1. Isn't it, class? I've been beating that drum. I hope you're getting it. All right. Minus, what is this? Well, that's 1 minus, technically, exp of minus, and it's going to be what? We just did this, didn't we? 2 minus 1, right? So this is what? 1 minus 1 goes away. The 1's go away, and it's going to be exp to the minus 1. Isn't it, class? And what is, I don't know. Doesn't, are you all with, what is it? 0.3? What is it? It's 0.3 something, isn't it?
Yeah, 0.3678.
Don't worry about it. Oh, we got this. What's next?
And then what is the probability that the random variable lies on the interval x greater than 1 but less than or equal to 3?
All right, now he wants this. Probability from 1, 3, right?
Yes.
What would that be? Well, it would be technically f of x of 3 minus f of x of 1, correct? All right, what is f of x of 1? Just look at it. Well, when x is 1, I have 1 minus 1 is 0. What is e to the 0?
1.
What is 1 minus 1? 0. So this one you don't even have to evaluate right here. What's f of x of 3? 1 minus exp, right? And this is going to be 3 minus 1 is 2 of the minus 2. And I don't know what that is, but it's a lot big. It's close to 1. I don't know.
864, 865.
Something like that. 865. It's okay. You all with me? Is there another part to that one? All right, I'm going to ask you something now. Now, on an exam or a quiz, I don't try to force you to do integration by parts. Your calculators by this time have the ability to do symbolic integration, don't they?
If you have a,
You want to do integration by parts? Have at it. I mean, I'll do it for you. So I'm going to ask for now hear me, I'm going to ask for the mean, hear me, the mean, and I'm going to ask for the first and second moments. I gave you the cumulative probability density function, right? I need the density function, don't I, class? Hear me on this, everyone? So I have to take a derivative of that. Let's do this over here. We're going to be doing this in the next section, but I just wanted to get this out of the way and give you a little running start on it. So here, I mean, now I need the density function, the probability density function of x, that I'll just call f of x, small f of x. And that's the derivative of capital F of x with respect to x. So when you take a look at this, a is 1, right? We're taking a derivative of this. We're going to take the derivative with respect to x of, and it's really e to the 1, if you look at this. It's e to the 1 times e to the minus x, right? Just expand this. And I'll put the minus sign in a second. We've got, let me do it this way. There's actually a minus sign here, right? If you take this right here and multiply that, you get e to the minus x and e to the plus 1. Do you agree with that?
Where'd the one go?
It didn't go anywhere. Just take this. If I go
the other one minus.
exp, well, we're taking a derivative. That's a constant. It'll go away. Do y'all follow me? Everybody on this one? I don't want to go too fast, but I'm assuming you got this, all right? So what is this going to be? Well, I have e to the 1 stays there, right? Now I have e to the minus x derivative is minus and minus is plus, and it's just e to the minus x. And that would be f of x, right? And this is true for x. In this case, it's greater than 1, right? Or equal to 1, and it's 0 else. All right, so, do y'all agree with this? You can, matter of fact, you can just call this simply a constant k times e to the minus x. That way, the k is e to the 1. With me? All right, let's get, how do you get the mean value? I'm going to put it down mathematically. What is that? This is what? The expected value of the function x, right? I just put x down there. That is going to be the integral from 1 to infinity. That's the range over which it's not 0, the density function, right? Times x times the probability density function, which is going to be k times e to the minus x dx. And I'm going to take that k out in front so you can see this. Now that integration probably looks familiar. Remember doing integration by parts? Isn't that an integration by parts? U du, right? U would be x, du would be e to the minus x dx, and we could do it that way. Do you agree with this, class? How many remember integration by parts? How many don't like integration by parts? Double for me, especially the long ones. So you have like x cubed, sine of x, cosine of x.
Oh, no.
Oh man, because you know, anytime you see a sine and cosine, if you let u be sine of x, then du is cosine of x dx, and it gets one of these. Oh, it drives you out of your mind sometimes because you got to keep on expanding. But your calculators don't have that problem. They can do this in a heartbeat. So what is this on your calculator? I'm trying to get you to use your calculators if you haven't seen it yet. The reason I'm doing that is because on tests and quizzes for this class, one of the biggest stumbling blocks are your calculators. And when I teach EMAG, when we get into that, how many have had EMAG 1 here? All right, remember with transmission lines, you have the Zn is equal to Z naught times ZL plus J Z naught times tangent of beta L, beta L over stuff. Well, on calculators, you go nuts sometimes punching that stuff in if you haven't done it many times, know how to do it. And the mistake is not understanding the formula, it's actually evaluating it with your calculators. That's the reason right now I'm trying to do this, because if that was a problem back in the day when you took EMAG 1, this will be a problem for you now, okay? Just do this. What do you get? And you can give me the value, because this is e to the 1. I didn't do it on my calculator. I did it on MathCAD, but I know my calculator can do this in a second. What'd you get?
2e to the minus 1 times k.
It should, all right, so it's really e to the 1 times, what?
2e to the minus 1.
All right, just bear with me for 1 second. Let me show you something. So it's 2e to the minus 1 times k. K is e to the 1, right? What is this going to give me? What's e to the minus 1 times e to the 1? E to the, what is e to the 0? Yeah, it's just 2. Tricky little problem, isn't it? You all agree with this? Okay. Now, hear me. What is the second moment? Keep your calculator out.
Just add x squared.
Right, I'm going to put the e to the 1 out in front. It's going to be the integral of x squared times e to the minus x dx from 1 to infinity. Now, this is one, if you try to do it by integration by parts, you do it twice. Don't worry. I mean, I'm not going to force you to do that, but it is, you got to do it twice. Unless you remembered it off the top of your head, and I didn't. U is x squared, du is 2x times,
You
huh?
can also use the table method.
The what?
If one of the terms derivatives goes to 0, you can just use the table method. So you would do the derivative of x squared and then the integral of e to the x, and then you would like make a table.
Yeah,
Plus minus, and then.
I haven't done that in a very long time. But, what is it? With this? Okay, yeah, he's right. All right. This has to do with a problem coming up. Y'all with me? So how many understand what I'm doing here? All right, now, for the bonus question, what is the variance? Do you remember the formula? Variance is always what? It's going to be the second it's really this, actually. It's the second moment, which is this is the symbol for it, minus what? The mean value squared. Do you all follow me in this class? Or we could put in what? X minus the mean, right, which is 2. X minus 2 and square it and do it that way, right? But this is what it's going to come to. Do you all remember this class? How many do? You're going to need this one. Hint, you will need to know this formula for the quiz. Okay, what is that going to be? Take a look. Well, we've got this, 5 minus 2 squared is 1. Y'all with me?
That's a great quiz question right there.
Isn't it? Especially if this was what? If this was e to the minus x minus 1 squared. Great question. I don't know why I'm silly right now. I didn't get a whole lot of sleep last night. Are y'all with me on this class? All right, let's do the next problem. It's not terrible, but most of the time, when you get frightened by a problem, you're overthinking it, you're looking at something. Anytime you have this, right, if this is a cumulative distribution, that one would work too. If it's e to the minus x minus 1 squared, look, it goes to 1, right? Follow me? You'd have to take a derivative of that, right, to get f of x. Now, the neat thing is, when you take a derivative of this, if it was squared, you're going to be able to get a u du very easily out of that. But I'm not going to do it now. I'm just telling you, it's not a hard thing. Your calculators will do that, though. Okay, is that next problem? Was it 2-23 or 4?
The one we just did was 2, 3. This one's 2, 4.
2, 4. Go ahead.
A random variable x is a probability distribution function of the form
This is capital F of x, right?
equals 0 for negative infinity is less than x, which is, or x is greater than or equal to negative 2.
X less than minus 2. Go ahead.
Equal to,
Huh?
less than or equal to negative 2. Yeah.
If this is continuous, it doesn't matter. Go.
A times 1 plus cosine bx.
All right, the cosine is wrong. Do you see that in my notes? You got to put a sign. The cosine is illegal. It will not work. Has to be a sign. Did anybody else try it with cosine? I tried it with cosine. Tom Denny's notes even noticed that. It will not work with cosine, it's an illegal function. But for this one, it's gonna be one minus,
Or 1 plus.
or 1 plus the sine of b times x, right?
Correct.
And this is for x,
If -2, x is greater than -2 or less than or equal to 2.
all right, well, I don't worry about the limits. And then it's 0 else, right?
1.
0 else, all right.
Oh,
Now,
it's 1 for.
oh,
x
sorry,
is
it has to.
Greater than 2
yeah,
or
I'm
less
sorry.
than.
It's 1 for x greater than 2. Okay? That's a density function, right? How do you get the probability density function? This is capital, it's integrated here, right? Capital F integrated already, right? What do I do?
Derivative.
Derivative, right? So I want the density function f of x. I have to take the derivative capital F of x dx with respect to x. Do y'all agree with this? I want to do this right for you. So it's really derivative of what? With respect to x, the first term doesn't matter, it's a constant of a, right? And it's times the sine of bx. We'll get a in a second. Do y'all agree with this? All right, so what is this going to be? Well, a comes out, right? Derivative of sine is, it's going to be cosine, but the b comes out, right? Cosine of bx, and this is going to be valid from -2 greater than x less than 2. Now, this is the probability density function over that range, and we got it from this. So back to this thing, right? We know this is a cumulative distribution function, right? And it has to, if you looked at this function, here's the density function. Without putting in the values, it's cosine. So it goes from -2 to 2. A cosine function is going to have this kind of form, isn't it? This would be, and this would have a peak value of AB, and this is going to be cosine of BX. So there's a couple things I'm going to mention. One is, this function, when x is equal to 2, has to be equal to 1. Do you agree with that? And the other thing is what?
Oh, interesting.
Isn't that right? That has to be equal to 1 when x is equal. So I'll put this down over here. And there's a second thing that happens too. We'll get this. So I know that A1 equals A times the quantity 1 plus the sine of B times, and then when it's 2, B times 2 or 2B, right? Of 2B here is going to be 1. And the other thing I know is, if you look at this density function right here, it goes to 0 at 2, doesn't it? Can you all follow me on this? Y'all understand that, right? All right, so what is that going to be? So then you have this function, we have 0 equals A times B times cosine of B times 2 or 2B, right? Y'all agree with that? Follow me? All right. Now, does this A and B have any bearing over here? How about we divide both sides by A and B? What's 0 by A and B? 0, right? What's the cosine of 0? What's an inverse? When is cosine 0? Pi over 2. Agree, class? So we can deduce that 2b is equal to pi over 2, or b is equal to pi over 4. Do y'all agree with that? Isn't it? Radians. Agreed? Now, what's a? If that's pi over 4, look back over, or look here. So if that's pi over 4 times 2, that's pi over 2, right? What's the sine of pi over 2? 90 degrees, right? 1, isn't it, class? Y'all follow me on this? So 1 plus 1 is 2. What does a have to be? 1 equals 2a. A is 1/2. Do y'all follow me? How many understand this right here? I'm getting some ugly looks. I don't trust you. I don't trust me either. It's right, I believe. A equals 1/2. Agreed? So we got A and B. Is there another way to get B? Well, here's another way. Just listen. You know this function is 1 when x is 2, right? That's it. When is it 0? 1 plus the sine of minus 2b. Isn't it, class? You agree with that? Isn't it 0 back when it took minus 2? Follow me on this, guys? All right. So if that's the case, what can you deduce? Well, for this one to be 0, this has to be minus 1. Follow me? Now, the sine of minus 2b is minus 1. Sine of minus x is minus the sine of x, right? So you can get what? You can actually get minus the sine of 2b is 1, or that's minus 1. Put it in here, and you're going to get, this is 1 right there. Do y'all follow me in this class? How many see this right here? Now you see, just look at this. Do we have 2 equations, 2 unknowns? It's solvable, right? It's determined uniquely. You agreed? You can do it that way. You with me? I take the derivative all the time to show you the density function. To me, it's more valuable. What's this next part of this question? A and B, and what else?
On the probability that x is greater than 1.
All right, I'm gonna do it with this. Now, we could do it, how could we get this? Since A is 1/2, I might as well put it in here, and B is pi over 4, how could you, we'll do it both ways. So if I wanted the probability that x is greater than, what was it, 1? How do I get that? 2 ways to get it. I could do what? This, I'll put A times B. A is 1/2 and B is pi over 4, so that's what? Pi over 8 here, right? For the density function, agreed, class? And this is f of x here. So what we could, and this is pi over 4. You could do it 2 ways. You could take this function and integrate it from 1 to 2, agreed, class? Or, since we already got the integration, right, we could take what? F of x, the cumulative distribution function, f of what? Of 2, right, which is going to be 1, minus f of, capital F of 1. Do you agree with that? Agreed? I go to 11, right? Okay, I got time. All right, so what's that going to be? What is f of 2, guys? Just look. Just look over here. This is from minus 2 to 2. This has to be continuous, all right?
1.
So it's 1, agreed? So it's 1 minus, what's f of x of 1? Well, what is it? I'll write it down. It's minus quantity what? 1/2, right? And then it's going to be 1 plus the sine of pi over 4 times 1, or sine of pi over 4. Is that right? What's that going to be? That's 1 minus 1/2, and here we have 1 plus, what is the sine of pi, what's the sine of 45 degrees?
Square root 2 over 2.
1 over square root of 2. Yeah. Plus 1 over square root of 2, or about 0.707, agreed, class? So what is it? Just tell me. 1 minus 1/2 is going to be 1/2. 1/2 minus 1 over square root of 2 is 1. You can multiply top and bottom. Well, go ahead. What is it?
0.146.
Is that from a calculator or from the answer book?
Calculate.
Is that right, class? This is not a hard one, but people make them. Is that right? Okay, good. All right, that's that. What's another part of that question?
X is negative.
All right, now look, just hear me. They want the probability that x is negative. Listen, this is the density function, right? It's the area under the curve. Can you see this as a symmetric function, about 0? So what does it have to be? X less than 0. Here's 0. It's this area, right? Isn't that area this area? Doesn't this area and that area have to be 1? This is a half, isn't it? How many see that? Sure. So that would be a half for that part of the question. Is this, the way I'm teaching, is this getting to you guys? I'm trying to, I could just give you a lot of formulas and stuff, but applying them at least seems more useful to me. What's next in that problem?
That's it.
That's it? All right, now we go to, is there one more or not? In this section. I gave you problems in section 4, didn't I? All right, let's do 2-4, but they rely on prior answers. But that's okay. We can get these prior answers very quickly.
I think we did most of them.
And
Because
so-
like 2-Tech 4.1 is to
Yeah, well,
find the random variable from problem. 2-Tech 3.2, find like the mean value of x, the mean square value, and then the variance.
all right, so that's 2-4.1. Isn't that the x equal to minus x1?
The 2-Tech 3. Oh, never mind. This is 2-Tech 3.2, and we did not do that. We did 2-Tech 2s.
All right, what is 2.3.2? This, I did them all last night. They're easy.
Yeah. So 2-Tech 3.2 is finding the problem. Okay, so it's just kind of leapfrogging back. and
Yeah,
forth. All
it's
right.
gone, it's taken prior stuff.
Yeah. So from 2-Tech 3 or 2-Tech 2.3, which was the a parentheses 1 minus exponent negative x minus 1.
And this is for x greater than 1, right?
Greater than 1, less than, and then.
And or.
And so 2-Tech 4.1 is asking for the mean value of x, the mean square value of x, and the variance of x.
We did that. You remember that? We did that one. But I wanted to do it when we had it up. All right, let's do the next. We did this one. So this is next one, 2-4.2. Go ahead.
And that's asking for the random variable from problem 2-Tech 2.4, which was the a parentheses 1 plus cosine mean x.
Here. We had we had capital F of x. This is the problem. And this is problem 2-2.4, right? And this is the one that we found out to be a was 1/2, right? And then it's times 1 plus the sine of pi over 4x. And that's from x greater than minus 1, or 2, pardon me, greater than minus 2, less than 2, I believe, right?
Yes.
All right, now what does he want on this one?
And he wants us to find the mean value of x first.
All right, remember I did this one? I took a derivative of this to get the density function. That was just on the board. Do you all see, remember that, guys? Once I had the density function, I got the mean value by doing what? X times that and integrating, right? Do you all remember me doing that? It was just a second ago. I think he wants mean squared, right?
The next one is the mean square
All
value.
right, so I'll just put this down. The mean value of x for this one was 2. The mean squared value for this one was 5, right? Take a look. And then what? He wants the variance, doesn't he?
He also wants the third central moment
Okay.
of x.
Now, we didn't do that. We're gonna, but it's gonna, I'll show you this. It's gonna be 0. All right? When you have any kind of symmetric distribution, and I'm gonna spend just a second on this one and slow down, but I want you to see this. So this right here is the problem I'm talking about. I got the density function for this one. When I put this function up right here, I had the f of x was equal to really what? It was pi over 8 times cosine of pi over 4x. And this is for x greater than minus 2, less than 2. Do you all remember this one, class? All right, now, that's the density function. We got the first moment. You use your calculators, right? Or the mean, sorry. We got the mean. We got the second moment. And what was that? That was 5, right? We got what? The variance for this one is going to be this is x squared bar. X squared bar minus x squared, and that was equal to what?
1.
That happened to be 1, right? And what's the standard deviation? 1. Y'all with me? Square root of 1 is 1. Follow me? All right, now over here, that's the density function. He asked for the third moment, right? The third central moment, correct?
Yes.
That's a symmetric function. If I plotted that, if you take a look at this, x versus f of x here, it's this. It's basically symmetric. It's a cosine function. And the peak value here is pi over 8. And it goes to 0 here at -2 and 0 here at +2. Cosine function. Now, you all see it's symmetric about 0. When they want the third central moment, they want the expected value of x cubed. That's the integral from -2 to 2 of x cubed times f of x, right? dx. Now, f of x is an even function. Do you all follow me on this? How many know what an even function means? In your own words, what is an even function? Anybody? F of x is equal to f of minus x, right? It's some, if you took the function and folded the paper about x equals 0 from right to left, they would overlap. An odd function, you would have to take it and then flip the page and fold it over, right? So for this one, this is even, and it's x squared is odd, right? Odd times even is odd. Agreed, class? What happens when you integrate an odd function from minus a to plus a? Always 0, isn't it, class? You don't have to do an integration. You all with me? If that was the fifth moment, if it was x to the fifth, 0. X to the seventh, 0. Y'all, if it's x even, then it isn't. I mean, if this is going to be an even function, you can't do it. You all with me? Then you have to evaluate. So this is 0. Is that the answer he gave us? I'm sure it is.
Yeah, I had to pull up the answers, but that looks right.
I mean, does anybody have the answers pulled up? It's 0. What's the next part?
The variance of x.
What's that?
The variance of x.
All right. Now, I think we did this here, right?
Yeah.
We got the variance here is 1. I hope that's right, if you can tell me. Variance.
No.
Oh. What?
That is 0.75. I think you used the wrong
What?
values for the first two parts. Those were from a different problem.
Oh,
This is 242, right?
This is 242, yes.
Yeah, that's the values for 241. The 2 and the 5.
okay. Well, hold on. Is it? I'm sorry. That's the x e to the minus x stuff. Yeah, I'm sorry about that. This, the mean value for this was 0, right? For this one. I'm sorry, you're right.
Yeah.
All right, and then the mean squared value we did, I forgot what it was. What was it?
0.758.
Yeah, I'm sorry about this. And that means the standard deviation, since the mean value is 0, is just the x squared means, or the second moment, which is 0.758. I'm sorry about this. And this would be the square root of that, 0.758. I'm sorry. What is this? He's looking at. You with me, class?
0.871.
Is that right? Okay, good. What else does he ask for?
That's it for that question.
All right, now I'm going to tell you what, I'm sorry I made a mistake about those. I am trying to hustle through here, but y'all follow me? The reasoning behind it. Here's the deal. If you have a perfectly symmetric or an even function, let me do it that way. Even function about 0 for the density function. All the odd moments are 0. The first moment would be the mean is 0. All right. Then if you take the third moment, it's 0. Third moment is 0. All those are 0, and that's nice. Okay, go ahead.
All right, so for 2Tech 4.3, this is different values.
Okay, is this the same, a different function, right?
Yeah, it's not using anything from previous questions.
Okay, good. Hold on. I wanted to get through these today, and I think I'm gonna make it. This is where you guys last time. All right, 2- what?
2-4.3.
Got it.
It's a random variable, capital Y, has a probability density function of the form small f of y equals capital KY.
Capital K times Y.
And then that's from y is greater than 0 to less than or equal to 6. And then 0 everywhere else.
0 else. Bear with me, I know you guys have been sitting here a long time. He's gonna ask us to figure out what K is. Y'all hear me? So if you look at this, it exists from 0 to 6, and it's just gonna be something, if this is Y, if it goes from 0 and this is 6, it's doing this, and this would be just 6K here, right? Now that's the density function. What do you know if you integrate a density function over the entire range it has to be? 1, all right? Can you see the area under this curve? If you just look at this, you could, we could integrate this and we get what? Ky squared over 2, right? From 0 to 6, right? Or what can you really do? This is 6, right? This height is 6K, right? So it's 36K times 2 would be equal to, y'all follow me? This area right here, or I can just do it this way. It's going to be 6K right there times 6. Sorry, that's what? That's if it was a rectangle. Got to divide it by 2, right? And that equals 1, right? So that means 2 over 6 squared is really 1 over 18, and I believe that is the value of K, if you take a look. You agree? Hang on. It's right. Keep going. Next one.
And then next is find the mean value of y.
Okay, now what's the mean value going to be? Let's do it over here. Just a lot of the same stuff over and over again to make sure. So if I want the expected value of just y here, it's going to be the integral of y, right, times the density function. And k is 1/18. I'm going to take the 1/18 outside times the density function. It's ky, so this is y squared dy from 0 to 6, right? That's going to be 1 over 18. And it's going to be y cubed divided by 3, evaluated from 0 to 6. Or here it's going to be what? 1 over 18 times 3, right? And then it's going to be 6 cubed. So what is that? 36 times 6. 36 by 18 is going to be 2, so it's 2, right? Right here. And it's going to be times 6 and then divide by 3. Is that right? So that's what? That's 4, isn't it? Is that right? Y'all with me, class? What's the next part? So that's the mean value?
And yes, that's the mean value, and then find the mean and square value.
How do we get mean squared again? This is the expected value of y squared, correct? Again, same deal as we did before. This one I'll be a little more careful of. It goes from 0 to 6. The density function was going to be what? It's really 1/18 times y. Then it's going to be times y squared dy. Do you all agree with that? Now get out of your way. Everybody? So, what's that going to be? Take the 1/18 out front. Just use your calculators. And then I get y cubed integrated as y to the 4th, right? Over 4, evaluated from 0 to 6. What is it? Is it 18? Did you say 18? Okay. I'll take your word on that. We could do it, right? So that's 36 times 36, so we get 2 times 36 over 4. Yep, you're right. Okay, what next?
Find the variance of y.
Guys, how do you find the variance now? Please remember this. Variance is this, right? This is the variance of x. This is the symbol we use. It's what? It's the second moment minus the mean squared. Second moment was 18, right? Minus the mean is 4, right? So it looks like it's 2, is that right? Is that the answer? What else?
And then find the third central moment of y.
All right, now, we could do this 2 ways. For the third central moment, what are we going to do? This becomes y cubed. Do you agree with that? We could integrate it that way. But here's some formulas. I'm not going to, we'll just do it this, we'll do it this way. I'm going to do it this way. This is y cubed, right? This becomes y cubed. What happens over here? Now I get, that's y to the fourth integrated, is y to the fifth. I have 1 over 18, right? Then I have y to the fifth over 5, and that's 6 to the fifth over 5. This is the third moment, right? All right, what is that going to be? I'm glad you got calculators. After a point, I start not liking to do this in my head. It seems to be a little irritating. Is that the right answer?
86.4.
So part E
Yes.
is negative 1.6, I think.
What is part E again?
Part E is to find the third central moment of y.
I got 86.
What we just did.
Huh?
That's what we just did.
Central, no, this ain't the central, this is the third moment. The third central moment is this. What? What do we have to do for the third central moment? Do it here. A central moment is always where you take the function, subtract the mean from it. That's a central moment, and take it to that power. So the third central moment would be, really, it's the expected value of, and that would be of y minus the mean value cubed. You with me on this? Now, there are formulas for this. But this technically is what? The integral from 0 to 6 of the density function, 1 over 18 times y, and then it's times that cubed of y minus y bar. What is y bar again? What does it mean? 4? 1 minus 4 cubed dy. That would do it, right? You can see one thing. When you cube that thing, you're going to get a y cubed that is the highest power. Then you're going to get y squared, y to the first power form, and then a constant. Well, y squared we did. We've got the second central moment, right? We've done that. We've got y bars, the mean. We can substitute those in and make it very easy because this integration is a density function. Doesn't he have a formula for this? Where he says this is, if they're odd moments. Take a look at the answers, answer man. Doesn't he have a formula for that, or does he actually evaluate it? For this is the third central moment. This is the third moment. Huh?
He's got y minus 4, and then he's got that thing squared.
That's it.
of y.
Not squared, cubed.
He's got it squared.
This is the third central moment
You got the right answer. Negative 1.6.
for this right there. It should be cubed. Has to be if it's a.
Squared, it would go to 0.
What's that?
If it was squared, then it would go to 0, it would be odd. If that one.
Yes. You're right about that. But this is third central, and no, it goes from 0 to 6. It wouldn't be 0. See, it's not from minus 6 to 6. So it wouldn't be 0. But this right here, can you?
It looks like he's got a 2 over 18 instead of 1 over 18.
For what?
He's got, or like his formula he's using to get negative 1.6. He's got the same thing, like the effective value of y minus y bar squared, but then he's got integration from 0 to 6, y minus 4 squared, and then times 2 over 18 dy.
Well, can somebody do this one? We can.
That was negative 1.6.
That's right. Minus 1.6. And does he have minus 1.6 for that? So whatever he's doing, it worked out. And I think it's a trick with the formula expansion. But for all these moments, central moments and stuff like this, they're expansions. And here's what I mean by that. If you take a look at this just for a second, bear with me now. If you look at this just for a second, really, this is a density function, right? So if you think about this as the integral from 0 to 6, and I'm just going to leave it as f of y here. Now, square this out. Cube it out. So first, the highest power is going to be y cubed, right? Right there. Then you're also going to have a constant at the end that's going to be minus 4 cubed, right? Right. Actually, guess what? Let me do this. It's going to be plus minus 4 cubed. Then you start getting the cross products, where you're going to get 2 times y squared, and then you're going to have, what is it, minus, I can't do that right minus 16y and stuff, but here's the deal. When this is gonna have, you're gonna have plus some constant, I'll call it alpha y squared, plus beta y, and I've got the constant there, dy. Now, hear me, that's a density function times a constant. Forget the constant. Density function integrated over the range is 1. You all hear me? That constant just comes out in front. This, when I have y squared times the density function, I integrate it over the range. Now I get the second moment. Do y'all hear me? So we can replace that with the second moment. This is the first moment. Y'all see that? And that gives you this remaining to do, which we did over there. All right, so you can plug that value in there and get it. I know I'm out of time. I'm over time, actually. Next time, I'm going to give you some reading. We'll talk about more of this applied. This is going to be in section 5 and 6 in the old book that I posted. Hear me? I'll give you stuff. I'm sorry I didn't get to the theory, but this is important. You guys see the problems. Did this help you guys at all? How many tried those problems, by the way? I don't know how much it helped. I know that some of these things get a little hairy, especially when you got integration by parts stuff. That drives kids nuts. Thank you.
Thank you.
Quiz Wednesday, not Monday.